Okay, welcome back to Terence Payne Engineering. Okay, and we are going to look at Electrical Principles Unit 5 using Nodal analysis. Okay, now I'm hoping that I'm able to get this on camera as I would like it to be. Okay, let me just make sure. I'm going to try to deal with each section close up. Okay, within reason. One second, let me just make sure I got this. I don't want you straining your eyes. Now here we have a user nodal analysis to determine the current Ix and amount of power supplied by the voltage source in the circuit of figure 3.3. Now this is figure 3.3. Now here again, as I've told you, you need to draw out the diagram. Okay, put pen to paper. Okay, do not forget it. Do not try to do it off the screen, because when you draw it out, you're telling your brain what you want it to do and what you are expecting from your brain to function as. Okay, so let your brain do the work by giving it the information that it needs. Okay, now at this level now, some of you will be familiar with a lot of this yourselves already. Okay, circuit for problem 3.3. Okay, now I just lost the shade there just a minute ago. Just make sure that that we have this in view. Okay, want to make sure that it's in view and I'm well lit, that I'm not having any shadows. Okay, that seems to be strange. Okay. Now draw your diagram out. Here you have your source, your resistors. Okay. Now I know these are old-fashioned type resistors, but it doesn't matter. They're still representative of resistors. And you have here your second source. Now, solution. At node V, application of Kirchhoff KCL gives. And KCL stands for Kirchhoff's current law. Okay? And you should all be familiar with Kirchhoff's laws by now. Okay? So I'm not going to be going through that with you. You'll find it in one of my other presentations. Okay? So let's look at it. Now one of the things that I find very odd is that we got current going that way, right? Because the arrow is indicating upwards. And for me, that indicates a positive flow of current. But as you can see, within the formulation, they've given it a minus flow of current. Because for me, again, I would be thinking if minus, then current would be going that way, basically. But it depends as to whether, I suppose, we're looking at conventional current flow or electron flow. But for me, we'll accept it as it stands, as they may know better than myself. So we'll go with minus 9 volts, plus V over 2, plus V over 4, plus V minus 40 over 8. Now, why over 8? 8 ohms resistor, your 2 ohms resistor, and your 4 ohms resistor. And here you can see Ix, and that is the current flowing through Ix. That's what we're trying to find out. Okay. Now again, writing this out, that's our first part here, okay, that we've looked at. It's the first part we've looked at, and that represents the what I would call as mesh 1 or I1, for the want of a better word, basically. Okay. Here we then have V. V, and here is your V on in diagram here. Okay. And that's giving you as 1 over 2, 1 over 4, and you have 1 over 8, which is here. So these are your pieces of units here. Okay. Again, draw out the diagram. Make sure you understand where each piece is coming from and which piece is represented by. Now, I'm not going to do all the calculations for you. You'll need to do some research for yourselves to make sure you understand the concept behind it. Okay. And here we're applying Kirchhoff's current laws. Okay. Equals 9 plus 40 over 8. Now here, I've done a little bit of rough work here myself. So what I try to do here is to have a look at it for myself, and I trying to simplify that both sides would be multiplied by 8. I don't know why I got 14 there. Multiply both sides by 8, okay? That's what I said. I have 14 here because this 14 here comes from, tell me where, comes from here. Okay, so that and that is the same, is what I've looked at, okay? That's where my result came from. Now, let me make sure that I'm not getting myself confused, okay? And then divide both sides by 7, okay? And what I've done here is you get 7V because you want V on its own, because you need to know what the voltage is. V then equals 16 volts. And you can see what I've done here. Divide both sides by 7. V equals 112 over 7 equals 16. Okay. I did say multiply both sides by 8, did I not? Okay, let me just make sure that I've put that right. If I didn't, multiply both sides by 8 and divide both sides by 7, okay? And that gives you your 16 volts, which is your answer here, okay? Now, you're going to do this for yourself. You need to make sure that you understand the concept behind it. And some of you have a good perception of it, okay? So Okay, so I just make sure that I haven't missed anything out, because this is not quite easy to explain as I would like to have done. But let me just drop this volume, just the size down, so we can make sure we get it in place. Okay. This is now, please note, this is just my scribble, okay? But you can see that here is this here, okay? Right? That is this, okay? The same thing. I just trying to illustrate how it was achieved. The current Ix is then given by Ix equals V over 4 equals 16 over 4 equals 4 amps. Okay, so you know V is 16 as we got it here, and the Ix in the diagram is 4 ohms, so we need to have the current flowing through. So the current flowing through that is 4 amps. Okay. So to find the power supplied by the 40-volt source, we need to first find the current I flowing into its positive terminal. I therefore equals V minus 40 over 8, which here you have 16 minus 40 becomes what? So 8 into 24. And why do I say 24? So tell me, why do I say 24? Because 16 minus 40 is 24. Okay, just checking that I am right. Okay. Now this is for you now to continue to look at. And you can see that here it's therefore minus 24. 8 into 24 goes 3 times, it is minus 3 amps. Hence P equals V times I equals 40 times minus 3 equals minus 120 watts. The minus sign confirms that the voltage source is a supplier of power. Okay. So again, do this for yourselves. I'm not going to. Some of you are quite good at this yourselves, so don't need any introductions. This one here, I'm a little bit dubious about. I won't look at this here too much because I'm a little bit. I wanted to have the diagram for it, but I haven't got any diagram for it. So I'm just going to put it as a question mark for the time being. Okay. So we can leave that for now. I make no apologies for that in any shape or form. It's just one of those things that happens, and it's important that we show that we're not all perfect at any point in time. So let's look at the other one. Problem 3.4 for the circuit in figure 3.4, and this circuit here in figure 3.4. Now, solution at nodes V1 and V2. Now V1 minus 16. Now again, I am dubious about this 16 because I'm looking at current going that way as being positive. I'm sure that you probably would agree with my perception as well, but I don't know why we look at it in that way. Probably there's a reason for that, but maybe. Okay, right. At nodes V1 and V2, node 1, V1 minus 16 over 1 plus V1 over 1 plus V1 minus V2 over 1 equals 0. Now you're almost putting this down as a kind of simultaneous equation. So keep that in mind. Okay, and node 2, V2 minus V1 over 1 plus V2 over 1 plus V2 over 1 equals 0. Okay? You have V1 and you have V2. Okay? You have VR. Now simplifying equations 1 and 2 gives 3V1 minus V2 equals 16. Minus V1 plus V2 equals 0. Again, you're almost looking at this as a simultaneous type of equation. Okay? Simultaneous solution of equations 3 and 4 leads to, thank you, V1 equals 6 volts, V2 equals 2 volts. Now voltage across VR equals V1 minus V2 equals 6 minus 2 equals 4 volts. I equals V2 over 1 equals 2 over 1 equals 2 amps. Okay. Now again, write this out for yourselves. I'm hoping that this is clear to see. And I'm not going to do everything here for you, but try to illustrate how you can better achieve and apply it for yourselves. Okay. Problem 3.10. The circuit in figure 3.10 contains a dependent current source. Determine the voltage Vx. So we're looking for the voltage Vx, which is here at this point. Solution. In terms of the node voltage Vx, Kirchhoff's current law gives Vx minus 6 over 2 plus Vx over 3 minus 2 Vx plus Vx over 6 equals 0. Again, you're applying a formulation. And that's for you to work out. I'm not going to do that for you. Vx therefore equals minus 3 volts. Now let me just see if I had extended this any further. No, I have not. What was the question in here? Let's just make sure we answer the question. The current circuit determine the voltage of Vx. And we have Vx at minus 3 volts. Okay? And that's interesting. Now my question here is, which Vx are we talking about? Okay. A dependent current source. I was looking at this and I could still be right, and that's still my view. Yes. I'm happy with that. If I'm incorrect, well, I apologize, but I'm looking at it from my perspective. Remember to adapt your learning to your perspective, okay? Apply mesh analysis to determine the amount of power supplied by the voltage source in figure P3.31. Now look at this. We have mesh, well, I'm going to call it, like for me, I1, I2 and I3. We have I1, I2 and I3, but we have mesh 1, mesh 2 and mesh 3. So mesh 1, 2I1 plus 3, you're looking at this here and this here. I1 minus I3. Plus 2I1 minus I2 plus 48 equals 0. Now 48, why does the 48 come in to hit? Because you can see here is your 48 volt supply source here. Okay. Now I'm not going to do this for you. You're going to look for this and put it in place yourselves and look at how they have arrived at the solution. Solution is I1 equals minus 8.4 amps, I2 equals 0.6 amps, I3 equals minus 4 amps. Current entering positive terminal of voltage source is I equals I1 minus I2 equals minus 8.4 minus 0.6 equals minus, and the minus makes a what? Makes a plus. So these two are added together. Okay? And gives you minus 9 amps. Okay? Now I'm hoping that this comes out good. I'm going to have to look at this on when I run it, before I run it out, because I wanted it to be large and massive, and so it comes up, so it like comes out at you in your face. So that's what I'm going to have to look at doing, bringing down. Okay. Yeah, that's good. I can go with that. Let me just make sure that I brought all the others into place as well, so you can see it. Okay. Right back now. Okay. So we can see what we need to be doing. Okay. Now all I'm doing here is making sure that you can see these diagrams and that I have made them large enough to be seen without you straining your eyes in any way or straining your brain to see it or anything of sort. Okay. Now let's look at this carefully. Make sure I bring this across so we can bring that into play. Okay. And I will bring him back. Okay, let's go a little bit more. Over there. Okay, good. You know, I didn't even check the page, which page I was on before I began the large aesthetic slide. Yes, we done on him already. Okay. Okay, yes, okay, good. I am happy with that. I am yes, I can do that, yes. Okay. And here's where we were, I think, yes. And I'm just making sure that you can see cells, okay. You see there that we add that, okay. Apply nodal analysis to find the current Ix in the circuit of figure P3.14. Okay, again, this is something that you need to be working on, and you need to work it up, apply the principle for yourself. Again, you should now be familiar with Kirchhoff's laws before, Kirchhoff's current law, okay? Well, I don't remember Kirchhoff's current law, even though I had to do the calculations the other day. But it's something that you guys will need to apply. I'm an old man now, so I've got my excuse. Okay. Look at each part in turn. Try and deal with each part in turn, okay? See where it comes through, come through too. Okay. In turn. Okay. You can see your pieces together, put them together. Make sure that they are just like you can see here that equals 6.25 amps. Okay. And let's look at the current. What was the question? It says find a current in Ix. Okay. Always look at the question. Here again, I'm surprised we haven't got any arrows indicating our current flow. But as you can see, now here we are looking at applying mesh analysis to find the mesh current in the circuit of figure P3.26. Use the information to determine the voltage V. So we need to find the voltage V at this point here. What voltage would appear at that point? Okay. And here we're looking at Kirchhoff's voltage law. And we have one loop, we have I1 and I2. Or you call it mesh 1 and mesh 2 if you prefer. But I tend to go with I1 and I2. I have no idea why, it's just habit, I suppose, for myself. But you'll find your own level, okay? Now look at this one, this part here particularly, because you'll notice you're trying to figure out what happened here. You can see that here they've multiplied out this piece here, okay, and 1/3 is 0.33, 0.33, yeah, basically, and times that will just give you 1. That's how you arrive at your 10 volts here, okay. Make sure you understand the process as to how they've achieved each piece. Some of you now should not be quite familiar with all this, okay. Okay, I hope you found this useful, and please again try to do your best. Becoming an engineer is a lifetime, it's for life, I should say. It's not just for tomorrow or today. It is a lifetime usage of your time and value. Just remember to refresh yourselves as you grow older to be up to date with your regulations and the knowledge that you will acquire. Okay, thank you. I hope you found this useful. Have a good day. Bye bye.